Hello everyone, welcome to my presentation. Let me start my topic by sharing a few words about my own background. Myself, J. Shruti from TTWREIS Girls Manur at Karasgutti. Today, I am very much delighted to share my topic with you. Today's my topic is from mathematics. Mathematics is not only used in solving problems. It is also used in dividing sorrows, adding happiness, subtracting sadness, multiplying lots of love and forgiveness. Here, addition, subtraction, multiplication, division are the four basic operations in mathematics, which are not only used in solving textbook problems, they are also used in our real life to solve our own problems and to lead a happy and beautiful life. So, let us move on to our main topic. Today's my topic is matrices and types of matrices. We learn matrices and their determinants in higher school classes, which are very important in our day-to-day life. For example, in classrooms, we arrange ourselves in rows and columns, is also an example for matrix. In assemblies, we arrange ourselves in vertical lines and horizontal lines, is also an example for matrix. So, my presentation is in three parts. First, introduction, which includes definition of matrix and order of matrix. And second, brief explanation about the types of matrices. And third, conclusion, summarizing the topic. So, before going to the introduction, let us discuss about an important person in the history. The word matrices was introduced by the English mathematician James Sylvester, but it was developed by his friend Arthur Cayley. Here, now let us discuss about Arthur Cayley. He was popularly known as father of matrices. Arthur Cayley was not only a great British mathematician but also a famous lawyer. Cayley worked as a lawyer for 14 years. While he was working as a lawyer, he published nearly 250 research papers in mathematics. And he was the first person who introduced multiplication of matrices. And he was consequently able to prove the Cayley-Hamilton theorem that every square matrix is a root of its own characteristic polynomial. So, here now let us move on to the introduction part. Definition of matrix. A rectangular arrangement of elements in rows and columns is called a matrix. Matrices are denoted by the capital letters A, B, C, D and so on. They are enclosed by the brackets. So, for our better clarification, let's see an example for it. Look at the slide. Here we have an example in that the elements are arranged in a rectangular manner in rows and columns, and they are enclosed by the brackets, and they are denoted by the capital letters A and B. So, I hope you have understood the definition of matrix. Now let us move on to the order of matrix. A matrix having m rows and n columns is said to be an order of m cross n, or we can say as m by n. Here we can see a general representation for the order of matrices, in which small a represents the elements in the matrices. Here the first suffix denotes the columns. Here first suffix denotes the columns and second suffix denotes the rows. Now let us see some more examples for the order of matrices. Here in the first example we have 2 rows and 3 columns. So 2 by 3 is order for this first example. If we see the second example, in that we have 3 rows and 3 columns. So 3 by 3 is the order for the second example. As like we observe the third example, in that we have only 1 column and 3 rows. So 1 by 3 or 3 by 1 is the order for this third example. Now let us observe some more examples to understand the order of matrices. Here in the first example, we have 2 rows and 3 columns. So 2 by 3 is the order for this example. Now let us observe another example in that we have 4 rows and 2 columns. So 4 by 2 is the order for this example. We have discussed many more examples in the order of matrices. The order of matrices are very important to understand the topic. Now let us move on to the next topic, that is types of matrices. Here we have wide variety types of matrices. In that, row matrix, column matrix, square matrix, rectangular matrix, zero matrix, identity matrix, diagonal matrix, scalar matrix, symmetric and skew symmetric matrix, equal matrix, and triangular matrix are some of the types of matrices which we are going to discuss in this session. Now let us move on to the first type of matrix, that is row matrix. If a matrix has only one row, then that matrix is called as row matrix. If we observe the first example here, in that example we have only one row and 6 columns. So 1 by 6 is the order for this matrix. If we observe the second example, in that we have only one row and 3 columns. So 1 by 3 is the order for this row matrix. If we observe a picture here, in that the students are arranging in one row and performing yoga. So here we have only one row and 5 columns. So 1 by 5 is the order for this image matrix. Now let us move on to the another matrix, that is column matrix. If a matrix has only one column, then that matrix is called as column matrix. Now let us see an example here. Here in the example we have only one column and 4 rows. So 4 by 1 is the order for this example. Now let us see a picture here. In that picture, the parrots are arranged in one column. Here we have 4 rows. So 4 by 1 is the order for this image matrix. Now let us see another picture. In that the students are performing yoga by arranging in one column and 5 rows. So 5 by 1 is the order for this column matrix. Now let us go on to the next type of matrix, that is square matrix. It is very simple. In the square matrix, number of rows are equal to number of columns. Now let us observe some examples. In that examples, in the first example, we have only one row and one column. So 1 by 1 is the order for this example. If we observe the second example, in that we have 2 rows and 2 columns. So 2 by 2 is the order for the second example. If we observe the third example, in that we have 3 rows, 3 columns. So 3 by 3 is the order for this example. Here in all examples, the number of rows are equal to number of columns. That's why they are called as square matrix. If we observe a picture, in that the students are doing yoga and by arranging in 3 rows and 3 columns. So it is called as square matrix because its order is 3 by 3. Now let us move on to the next type of matrix, that is rectangular matrix. It is quite opposite to the square matrix. Here number of rows are not equal to number of columns. That's why it is called as rectangular matrix. Now let us observe an example here. Here in the example we have only 3 rows and 4 columns. So 3 by 4 is the order for this rectangular matrix. Now let us observe an image. In that the students are doing meditation by arranging in 4 rows and 3 columns. So 4 by 3 is the order for this example. Now let us move on to the next type of matrix, that is zero matrix. If each element of a matrix is 0, then that matrix is called as zero matrix. Zero matrix is also called as null matrix. It is very simple to understand. Now let us see an example here. Here in the example, all elements are equal to 0 and the order is 2 by 2. If we observe the second example, in that we have 3 rows and 3 columns, but all the numbers are equal to 0, so it is called as zero matrix or null matrix. If we observe the last example, in that we have only 1 row and 4 columns. 1 by 4 is the order for this matrix. All the elements are equal to 0. Now let us move on to the another type of matrix, that is unit matrix. Before going to the unit matrix, now let us learn what are diagonal elements and non-diagonal elements. Diagonal elements, the elements which are arranged diagonally, are called as diagonal elements. The elements and other elements are called as non-diagonal elements. Now let us move on to the unit matrix. If each non-diagonal element of a square matrix is equal to 0 and diagonal elements are equal to 1, then that matrix is called as unit matrix. Unit matrix is also called as identity matrix. It is denoted by I, and the order of unit matrix is IN. Now let us see some examples here. Here in the first example, we have 2 rows and 2 columns. In that, the non-diagonal elements are equal to 0 and diagonal elements are equal to 1. If we observe another example, in that the number of rows are 3 and number of columns are 3. Here the number of rows are equal to number of columns, and the non-diagonal elements are equal to 0 and diagonal elements are equal to 1. Now let us go to the another type of matrix, that is diagonal matrix. If each non-diagonal element of a square matrix is equal to 0, then that matrix is called as diagonal matrix. Now let us see an example here. Here in the example, all the non-diagonal elements are equal to 0 and diagonal elements are 1, 8, 4, which are not equal to 0 here, and number of rows are 3 and number of columns are 3. So 3 by 3 is the order for this example matrix. I hope you have understood the diagonal matrix. Now let us move on to the trace of A, means trace of matrix. It is a type of matrix. Here the sum of the diagonal elements of a square matrix is said to be trace of a matrix. For example, let us take an example here. In that, let us consider the diagonal elements are 1, 1, 1. Sum of the diagonal elements means 1 plus 1 plus 1. Here the trace of A is 3. Because sum of the diagonal elements are equal to 3, so trace of a matrix A is equal to 3. I hope you have understood the trace of a matrix. Here we have discussed the unit matrix, zero matrix, diagonal matrices. Here we have similarities and differences between these three matrices. Now let us discuss the similarities between these three matrices. In unit matrix, in diagonal matrix, in scalar matrix. First, let us see the scalar matrix. If each non-diagonal element of a square matrix is equal to 0 and all diagonal elements are equal to each other here. Let us see an example here. Here in the example, the first example, non-diagonal elements are equal to 0 and diagonal elements are equal to each other, means they are equal to 3. If we observe the second example, in that the diagonal elements are equal to each other, means they are equal to 5. And all non-diagonal elements are equal to 0. Now let us see a picture for the scalar matrix. Here in the picture, the students are performing yoga, who are arranged diagonally, appearing same. Here we considered as equal to each other, and others are empty, so they considered as 0. It is a suitable example to understand the scalar matrix. Now let us discuss similarities and differences between unit matrix, diagonal matrix and scalar matrix. Similarities: in unit matrix, in diagonal matrix, scalar matrix, all non-diagonal elements are equal to 0 and they are considered as square matrix, because in unit matrix, scalar matrix, diagonal matrix, the order is n by n or m by m. Now let us discuss differences between these matrices. Here in the diagonal matrix, the diagonal elements are any other number except 0. In unit matrix, all the diagonal elements are equal to 1. In scalar matrix, all the diagonal elements are equal to each other. For example, 3 or 5 or etc. Now let us move to the next type of matrix, that is triangular matrix. We have two types of triangular matrix. One is upper triangular matrix and lower triangular matrix. Upper triangular matrix. If A is equal to Aij of order m by n is said to be upper triangular matrix if Aij is equal to 0 for all I is greater than j. Now let us see an example here. Here in the example, all the diagonal elements and non-diagonal elements. Here the element A12 is equal to 0 and I is greater than j. If we observe another elements, that is A21 and A31 and A32 are equal to 0 and they satisfy the condition I is greater than j. Here, now let us move on to the next type of matrix, that is lower triangular matrix. If a matrix A is equal to Aij of order m by n is a lower triangular matrix if Aij is equal to 0 for all I is smaller than j. Now let us see an example here. Here in the example, the element A12, A13 and A23 are equal to 0 in which I is less than j. Here I and j are the columns and rows. It is a suitable example for the triangular matrix. Now let us move on to the next type of matrix. Equal matrices. Matrices A and B are said to be equal if A and B are in same order and the corresponding elements are same. Now let us see an example here. Here in the first example, A and B are said to be equal matrices because they are in same order. The order is 2 by 2 and corresponding elements are equal to each other. In the second example, they are in same order, that is 2 by 2 and corresponding elements are also equal to each other. Now let us see another example. In that, the order is 3 by 3. So now let us move on to the next type of matrix, that is symmetric matrix. Here, before going to the symmetric matrix, let us discuss what is a transpose of a matrix or transpose of A. If A is equal to Aij is an m by n matrix, then the matrix obtained by interchanging the rows and columns is called transpose of A. For example, here the transpose of A is denoted by A dash. Now let us move to the symmetric matrix. Square matrix A is said to be symmetric if A transpose is equal to A. if we observe the example here, in that example, here A12 is equal to A21 means the element A12 is equal to A21 and they are equal to 2. And the element A13 is equal to A31 and the element A23 is equal to A32. This is a suitable example to understand the symmetric matrix. Now let us move on to the next type of matrix, that is skew symmetric matrix. Square matrix A is said to be skew symmetric if A transpose is equal to negative of A. Let us see an example here. Here in the example, the element A12 is equal to negative of A21 and the element A13 is equal to negative of A31 and the element A23 is equal to negative of A32. Here skew symmetric matrix. It is an example for the skew symmetric matrix. The zero matrix of order n by n is said to be skew symmetric matrix. Here if A is a square matrix, then A minus A transpose is a skew symmetric matrix. Now let us move on to the applications of matrices in real life. Coding and decoding messages is an example for the applications of matrices, and electrical circuits is also an example for the applications of matrices. Matrices are applied in our day-to-day life. Applications of matrices are very important. Here, for example, matrices are applied in coding and decoding messages. Here, soldiers use these matrices to encode and decode a message in order to communicate with each other in the battlefield. Another way they used these matrices is to keep secrets from an organization or a person whom they don't want to see the message and read the message. Here, this is how the soldiers used the matrices to encode and decode a message. Now, let us see another example for the applications of matrices. Electrical circuits. Matrices are applied in electrical circuits to find the total current passing through the circuits. Here, if we observe keenly, in that the electrical circuits is related to the physics and matrices is related to the mathematics. Mathematics is interconnected with physics here. Here, electrical circuits. Matrices are applied in electrical circuits to find the total current passing through the circuit. To find the total current passing through the circuit, we should know the Kirchhoff's first law and second law. Here, the Kirchhoff's first law is also known as loop law. It is also known as Kirchhoff's current law. The algebraic sum of currents in the loop is equal to 0. This is the Kirchhoff's first law. Kirchhoff's second law, it is also called as loop law or junction law. Here in this, the algebraic sum of potential is equal to 0. Here by the Kirchhoff's first law and second law, we find some equations. By these equations, we get some matrices, means these equations are converted into matrices. By solving those matrices, we get the total current passing through the circuit. Here, electrical circuits are very important in our day-to-day life. So, for example, the applications of matrices are conversion of energies into another useful energies. This is also an example for electrical. It is also an example for the matrices, means applications of matrices. Conclusion. Here, I want to thank to our Secretary Sir R.S. Praveen Kumar Garu and our Additional Secretary Sir Naveen Nicholas Garu and our Regional Coordinator P.S. Kalyani Garu and our Principal Ma'am Manjula Garu and our Mentor Ma'am Sri Lakshmi Garu for giving this golden opportunity, and also I am thankful to our Telangana government and also TSAT channel for giving this opportunity to share my views. Thank you. Happy learning.
కరెంట్ అఫైర్స్ 2021 జనవరి. అంతర్జాతీయం. అమెరికా 46వ అధ్యక్షుడిగా జో బైడెన్, ఉపాధ్యక్షురాలిగా కమలా హ్యారిస్లు ప్రమాణ స్వీకారం చేశారు. జాతీయం. భారతీయ సంస్కృతి విలువలను పరిచయం చేసే వినూత్నమైన గేమ్స్, ఆట వస్తువుల అభివృద్ధి కోసం కేంద్ర ప్రభుత్వం టాయ్ కథాన్ 2021 పేరుతో జనవరి 5న కొత్త కార్యక్రమాన్ని ప్రారంభించింది. ప్రధానమంత్రి ఆవాస్ యోజనలో భాగంగా మధ్యప్రదేశ్, గుజరాత్, తమిళనాడు, జార్ఖండ్,